Hi, I'm Finian Castorigas, team captain of Team 2839 Daedalus, and I am the lead board designer for the PCB The Change Challenge.
Hello, my name is Noah Martinez, and I am a freshman of 2839 Daedalus.
Hello, I'm Keegan Hammock, a sophomore of the Daedalus robotics team.
Hello, I'm Ophelia Decker, and I'm a junior on 2839 Daedalus.
Hi, I'm Ephraim. I'm a sophomore in Team 2839 Daedalus.
Hello, my name is Trevor Garcia, a sophomore on Team 2839 Daedalus.
The environmental issue affecting San Diego communities is pollution in our cities and storm drains.
It is important to solve this issue because excess amounts of garbage are polluting San Diego storm drains. We must prevent buildup of waste entering waterways later on. In this way, our SAD robot can take action to keep cities clean.
The approach to this issue that our team took was making a robot SAD. What SAD does is using the methane and thermal sensors will pick up and detect certain buildups of trash and leaves and just overall garbage within gutters and sidewalks and just curbs.
Now that I'm outside the Daedalus 2839 workshop, I can talk about our robot SAD, Sidewalk and Drainage Cleaner, to clean the clogged up waterways by attacking the source, such as the sidewalks and curbs. SAD would work with multiple sensors, thermal cameras, and temperature sensors.
Our board is a hat for the Potentia H7 by Arduino. We added several environmental sensors that measure air quality, pressure, and gases like methane to monitor the general health of the surrounding area. Using EEPROM and eMMC memory, we are able to store the data that we collect and upload it to an uplink point. Since SAD, our robot, needs to upload data to our database, we needed a wireless chip. We decided to use a FN-Link QAC6174 PCIe UART Wi-Fi Bluetooth chip. This chip allows us to have a Wi-Fi signal to our upload points. We are also allowed to have Bluetooth connections to our upload point, so we have multiple options in order to upload our data into our database. This also allows our robot to be easily serviced, as well as it allows our robot to communicate with other robots around the area. So in order for our robot to actually move, we needed a DC motor header, so we used a dual DC motor controller, and one motor is used for steering the robot, and the other one is used for both locomotion and moving the brush. We also used a camera, so we needed a camera connector, so we decided to use the CSI2 camera connector, so we can use a camera navigation API, so we can add automation to SAD. Automation is very important with our robot because without a human operator, this robot is able to run at all times of the day and without human interaction and human error. We also, the sensors that we used for detecting our gases and our ambient temperature and air quality were a Bosch BME 680 and a Sensirion SGB 40. These chips basically allow us to detect if there's any methane in the air or alcohol, but methane and alcohol are quite similar. And then the Bosch BME 680 allows us to see the air quality in an area. It allows us to detect temperature, pressure, so this is also a mobile weather station. We can use the data that we collect from our robot in order to help city officials find offenders of greenhouse gas emissions, like they're emitting more than they're reporting, because we can find high density areas of bad AQI or high methane content. In the meantime, this robot is also sweeping the streets as a automatic street sweeper in order to keep our streets clean and also to keep garbage out of our storm drain systems, because that is a huge problem here in Escondido, California.